Oh, hello kids. Sorry I didn't see you there. I was so interested in my book about rocks. Did you ever stop and think the whole world is covered in rocks and every rock used to be different? All the rocks in the world used to be melted rock, what we call molten rock, like the rocks that came out of the volcanoes. Today we will be talking about two different types of volcanoes, shield volcanoes and cinder volcanoes.
Isabella, the science gal.
Bella, the science girl.
Isabella, Isabella, the science gal.
Science rules. Sedimentary is part of the rock cycle.
Isabella, the science gal.
Bella, the science girl.
Science sedimentary is part of the rock cycle.
Isabella, the science gal.
But before we get to the actual experiment, we are going to learn a little bit about the rock cycle and the three different types of rocks. When rocks come to the Earth's surface, they come from volcanoes. These rocks get onto the Earth's surface, they get mushed together, and they blend to form a new rock. Rain and wind come over the Earth's surface, break down into sand, and sometimes enough water will flow through, and the sand pushes around. When they dry, they form together to make a new rock. And this, my friends, is called the rock cycle. It's how the rocks are formed, broken down, and then formed again. This has been going on since the Earth started billions of years ago. There are three types of rock that appear in the rock cycle. Over thousands of years, energy from the sun moves the wind and rain at the Earth's surface with enough force to break rocks apart into sand and other types of sediment. This is called weathering and erosion. When sediment is buried and cemented together, it becomes sedimentary rock, such as sandstone or shale. When rocks are buried deeply underground, they're in an environment that is very hot and has high pressure. The crystals and textures of the rock change as they turn into metamorphic rocks, such as marble or slate. The rocks that are deeply underground are put under a tremendous amount of pressure and high temperatures that are so hot they will melt, forming molten rock called magma. Sometimes magma cools and forms igneous rock deep underground. This is called intrusive igneous rock. Other times, magma flows to the Earth's surface and erupts from a volcano in which igneous rock is formed called extrusive. Rocks can affect the atmosphere. Erupting volcanoes send tiny particles of ash and gases into the atmosphere. Large volcanic eruptions can even reduce Earth's temperature for months or even several years. Rock is different in that its materials have undergone alteration by pressure, heat, or chemical processes, and has therefore adopted different structures.
So the first volcano we're going to be talking about are called shield volcanoes. Shield volcanoes have gentle slopes and a large width and size, as you can see here. Inside the shield volcano, there are layers of lava that ooze out during eruptions. Shield volcanoes also have low explosive tendencies. Purpose. Our purpose is to demonstrate what a shield volcano looks like during an eruption. Hypothesis. We think that when we pour in the vinegar with the baking soda, that the chemical reaction will cause the baking soda and vinegar to bubble up and rise, making it ooze out of the volcano. Materials used. We made a paper mache volcano with a cup inside, or you can just use a cup and a bowl. For the materials, you will need white vinegar, baking soda and a spoon, red food coloring, and a funnel.
First, you're going to want to get your volcano and put about 3 tablespoons of baking soda and a couple drops of red food coloring and mix it till it's completely red. Then, you're going to want to get the vinegar and pour in about 3/4 of a cup into your cup or volcano and wait for it to erupt. What we saw from this eruption was that the baking soda and vinegar came out a lot faster than we thought it would. Now you're probably wondering what just happened. Well, let me explain to you. When you add vinegar to baking soda, a chemical reaction occurs resulting in a carbonic acid reaction. When the liquid in the cup bubbles over, a gas is produced, representing the same thing that happens in a shield volcano. When a volcano erupts, gas is released and the lava bubbles out of the volcano.
In conclusion, our hypothesis was mostly correct and the experiment turned out good.
The second volcano we're going to be talking about today are cinder volcanoes. Cinder volcanoes have steep slopes, unlike shield volcanoes, and are narrower and smaller in size. Cinder volcanoes have layers of ash and cinder inside, and when they erupt, they have very violent eruptions. Purpose. Our purpose is to demonstrate what a cinder volcano looks like during an eruption. Hypothesis. We believe when we drop the Mentos in the Coke that the Coke will start to fizz up and shoot out, replicating how a cinder volcano erupts because it will be violent. We made another paper mache volcano using an empty 591 milliliter bottle of Coke. Or you could just use an empty bottle. And you're also going to want to get a can of Coke, a funnel, and a pack of mint Mentos.
If you're using a paper mache volcano, you're going to want to get the funnel and pour the can of Coke into the bottle and then drop in 3 Mentos and watch it erupt. However, if you're just using a bottle of Coke, you're going to want to open the Coke and drop 5 Mentos in the bottle and watch it erupt. Our eruption didn't turn out as we thought it would. We thought the Coke would shoot out flying, but it just fizzed out. We believe this happened because the first time we poured the can into the bottle, the Coke lost its fizz. The second time we used an old open bottle, so it didn't work as well. What was supposed to happen was when you put the Mentos in the Coke, it creates a process called nucleation, where the carbon dioxide in the soda is attracted to the Mentos. This creates so much pressure that the soda goes flying. In a real cinder volcano, when lava that is highly charged with gas bubbles erupts from a vent under pressure, it tends to shoot up straight in the air. In conclusion, our hypothesis was incorrect, and next time we should get a new bottle of Coke and drop the Mentos directly inside. Fun facts. Nearly all volcanic activity occurs at the edge of plates.
If a vent of a volcano is blocked with a rock, the magma is kept in place. However, if enough pressure builds up inside the volcano, the plug will be blown out and an eruption will start.
Sometimes a volcano gives signs that it's going to erupt, such as ground shaking, bulging at the side, and releases of gas.
When a volcano erupts, it makes a noise which can be heard for hundreds or thousands of kilometers.
After the initial blast, magma is released as lava, and it reaches 1,470 degrees to 2,100 degrees Fahrenheit.
Solid pieces of rock also come out of the volcano. The smallest pieces are called ash, and the largest ones are called bombs.
Poisonous gases such as sulfur and carbon dioxide are released into the atmosphere during a volcanic eruption.
Steam is also released. If a lot of steam is released, it may resemble a rainstorm.
When rain mixes with ash, black mud is formed.
Volcanic eruptions in the ocean can cause tsunamis.
Volcanoes may continue erupting for days, months, and even years, and then suddenly stop.
If this happens, chances are that the vent has become clogged with hardened lava, forming a plug.
Over time, the vent will fill in and the volcano will appear as just another mountain.
Hotspots are places within the mantle where rocks melt to create magma.
Thank you for watching this week's Isabella the Science Gal. And make sure you tune in next week so I can teach you about composite volcanoes and supervolcanoes. See ya!
Go. Whenever you're ready. Oh yeah. Go.
Oops. Shield volcano. Shield volcano.
Hypothesis. Hypothesis.
The materials used.
Woo!
This is whispered.
Observations. Whoa. Adriana, get to
Keep going, do that, come on, Iz.
Okay, well that didn't work.
Why didn't it work?